Okay, class, we're about to start the second part of section 2.1. It says here, number 1, if I offered you one of the two accounts detailed below, which would you choose? More importantly, why would you make that choice? Now, just glancing here, if I'm assuming that this account only goes to the 4th year mark, I would go with account 1 because I would have more money if year 4 was my last year. Now, let's take a more in-depth look at some patterns like the ones that began this lesson. Describe the change from one number to the next in the pattern 2, 5, 8, 11, 14, 17. Be very specific. That's way more than just specific. Way. Okay, so if we look here at number 2, we could say each number adds 3 to the previous number. Cannot get more specific than that. Okay, now, number 3. Repeat question 2 for the pattern 2, 6, 18, 54, 162, 486. Now, if you look here, we would be multiplying 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on. So each number is multiplied by 3. Okay, now we go here down to numbers 4 and 5. It says both of the lists above start at 2 and get increasingly bigger, but in different ways. In the first list, the value grows by adding the same constant number. This type of growth is called linear growth. In the second list, the values grow by multiplying. Multiplying by the same constant number. This type of growth is called exponential growth. Okay, now we turn over here to page 116. And it says here on page 116, it says, is exponential growth always going to result in faster growth than linear? Think about it. Try some examples and explain your answer. It just depends. Well, no, with exponential growth, that answer would be true. Because linear may grow faster in the beginning, but as time goes on, exponential growth will exceed linear growth. Okay, now it says the spreadsheet to the right shows an example of linear growth. What's the next value on the list? Now, if you look here at this linear growth here, it's growing by 10 because we have 35, 45, 55, 65. So then number 5 will end up being 75 and number 6 will be 85. So it says what's the next value on the list? It would be 75. Write a verbal description of how you would obtain the value in cell A6 from the value in cell A5. So all you would have to do basically is add 10 to cell A5. No, I'm sorry. It'll be add 10 to cell A4. to get A5. Okay, now we move on to number 9. It says, what would you type in cell A6 to calculate this value? Okay. Okay, class, I just caught an error that I had in problem number 8. I actually started that problem off correctly. Instead of A4, it should have been A5, and that would be to get A6. So we were supposed to add 10 to cell A5 to get A6. Now it says, what would you type in cell A6 to calculate this value? So you would type equals, and this is assuming that you use an Excel file, equals A5 plus 10. So this is what will go in A6. Now it says, what value would appear in cell A12? This takes either repeated calculations or some ingenuity. If you have Excel available in class, feel free to use it. Indicate how you got your answer. Now it depends. There's a couple ways that we could do number 10. If we assume that we had all the values up to A11, we could do the same thing we did for A6. We will go here, we will go at equals A11 plus 10. That would give us A12. Or if we don't have all of those values, we could start with A5. Or matter of fact, why don't we start with A6? So we could have 85 plus 10 times 6, which would give us 145. And that's what will go, this would actually be the answer for A12. Okay, now we will move on to page 117. Oh, by the way, just to go back here to problem number 10, just for a little bit of explanation. The reason why we would have this if we don't have cells 7 through 11 to get to A12 is because we know it's increasing by 10 for every cell. So we're going to go from cell 6 to cell 12. There are 6 cells. And then we will have to take our last value and add that to the 10 times 6. Now we go here to problem 11. It says, what's the next value on the list? Okay, now if we look here, we have 2, then we have 20, then we have 200, 2,000. The next value on the list, if you notice, it seems as though everything is being multiplied by 10. So the next value on the list should be 20,000. So the next value on the list would be 20,000. And let's use a comma here. It says, write a verbal description of how you would obtain the value in cell A6 from the value in cell A5. So what you would do, you will multiply A5 by 10. Now number 13. What would you type in cell A6 to calculate this value? You would type equals A5 and then times 10. Now one thing I want to show you all is this here. We know that this X means multiplication, but in some computer programs, they may have a star to indicate multiplication. So it's either the X or the star. Now, number 14, what value would appear in cell A12? This takes either repeated calculations or some ingenuity. If you have Excel available in class, feel free to use it. Indicate how you got your answer. Okay, now, what we would do is this. Since back in problem 13, we had A5 times 10, that means that A6 would be 200,000. So we know what A6 is. And we know to get from A6 to A12, there are 6 place values that we're going to. So 7, 8, 9, 10, 11, 12. So we will take our 200,000 and we will multiply by 10 6 times. And this will indicate, this will be for A7, A8, A9, A10, A11, and A12. So this will give us 200 billion. Yes, it'll just be 200 billion. And that will be our answer for A12. Now, for problem 15, it says, now let's study these two types of growth in a little more depth. Oh, by the way, just to go back, when we were back on page 116, this growth here was linear. This was linear growth. On page 117, this growth here was exponential growth. Now, again, let's study these two types of growth in a little more depth. By the way, we'll study linear change more in lessons 2.2 and 2.4. Then study exponential change in lessons 2.5 and lesson 2.6. It says, suppose that you're offered 2 jobs by a very eccentric but lovable billionaire. One pays $40,000 in the first year with a salary that increases by $10,000 every year. The second starts out at 50 cents a day, which I imagine probably violates minimum wage laws, but whatever, and doubles each month. Which job would you be inclined to choose and why? Now, I would tell you, I would be inclined, if I'm just looking at what I'm going to get right now, would be job 1. Because that's $40,000, and I would get increases of $10,000 per year. So I would pick job 1. That's what I would do from the hour start. So I would say job 1, $40,000 a year with $10,000 raise each year. It's hard to pass up. Now that would be my reasoning. Now your reasoning may be a little different. Now I'm not saying that this is correct, but I'm just saying initially if I just looked at it and didn't have time to calculate it, the $40,000 would sound more attractive. Now we go down here to problem 16. It says, how much would you make per month in the first year with a $40,000 per year job? So I would take my $40,000 divided by the 12 months. And that would give me about $3,333.33 per month. Going with a 30-day month to keep the calculation simpler, how much would you make in your first month on the second job? Okay, so basically, if I'm making 50 cents a day for a 30-day month, that would give me $15 per month. Or I should say $15 the first month, not per month. Okay, so it's $15 the first month. All right, now let's go to 18. It says, fill in the table below with the monthly salary for each job over the first year. Remember, the first one offers a raise only after the first year, while the second one doubles every month. Okay, so job one is going to be easy. Basically, it's going to be this value all the way down. So it's going to be $3,333.33 all the way down to the 12th month. So now job 2, you'll get $15 the first month, And we're just going to assume that it's 30 days in every month instead of the 31 and 28. So it'd be $30 the second month, $60, then $120, then $240, $480, $960, $1920, $3840, $7680, $15,360, and $30,720. Okay, this is how much you would make in a year. So, with number 19, it says, how much more money would you make in the first year if you had the foresight and math skills to choose job 2? Okay, job 1, we know it's set at $40,000. That's job 1. Job 2, after you add all of these values up here, it will give you $61,425. So, you would take the $61,425 minus the $40,000, and that would leave you an extra $21,425. So that's how much more you would make. It's quite a bit. Now we will move on to page 120. And we're told on page 120 we would do problems 1 through 4, and we would pick 1 or 2. So what I'm going to do is pick the first 2. So if we look here at number 1, the directions. There are many different ways for quantities to grow. In this lesson we study 2 of them, linearly and exponentially. Identify each scenario below as illustrating either linear growth, exponential growth, or neither. Show enough work to justify your answer, and if you can, find the next 3 values on the list. If you can't actually compute the next 3 values, make your best guess on what they would be, and describe how you got your estimates verbally. Okay, the next 3 values. If you look here, to go from $3.30 to $5.70, we're at, actually, if we look at this linear, because I would first look at everything linear, that means that it's growing by $2.40. From $5.70 to $8.10, it's growing by $2.40. And if you look at all the rest, it will be growing by $2.40. So they asked us for the next 3 values. So we would add $2.40 to $15.30. So we have $15.30 plus $2.40. So that would be $17.70. That would be one value. Then the next value would be $17.70 plus $2.40. That would give us $20.10. And then the next value, we'll take the $20.10 and add $2.40 to it. It'll be $22.50. So our next 3 values would be these 3. Now, they asked us for the work and explanation space. We actually showed the work up here, but we could tell that it increased by a rate of $2.40 for every mile. Okay, now they asked us for the type of growth. It's linear. Pretty straightforward. Okay, now we go on to problem number 2. We have this account value. We start off with $12,000 and we keep going. Now for $12,000 to get to $13,200, if you notice here, this goes up by $1,200. But then going from the $13,200 to $14,520, that's more than $1,200. So we know it's not linear. So we have to try the exponential. So this is how we could figure out the exponential. You would actually go backwards. So we would go from here to here, and we would do division. So we're going to go off to the side, Matter of fact, no, we could use our calculator. Let me pull out my calculator. So on my calculator, I would take the 13,200 and divide it by the 12,000. And that gave me 1.1. Now, we will try it with the next two values. We will try it with this 14,520. And we'll divide it by the 13,200. And it still gives us 1.1. We'll try it again. We will have 15,972 divided by the 14,520. Now, if you notice, it keeps giving us 1.1. So what we're doing here, we're multiplying by 1.1 for all of these. Even though we were going backwards, we're actually multiplying by 1.1, because if you notice, it gets progressively larger. So now, our next three values, we would take our 19,326 and 12 cents and multiply it by 1.1. And we're going to have to do a little rounding. So we could write that down here, the 19,326.12 times 1.1. And we could put 21,258.73. And then we would take that value, the 21,258.73, and multiply it by 1.1. And that would give us $23,384.60. And next, we would take that value, the $23,384.60, and multiply it by 1.1. So $23,384.60 times 1.1. And that'll be $25,723.06. So these will be your next three values. Okay, now work and explanation space. We actually showed the work here. So what we would have to do, we would say that first of all, it's not linear. Each year multiplies the value by 1.1. And the type of growth is exponential. And we are done.